Hello guys, I'm Herman. If you are someone just looking to visualize waveform on your electronics project and you don't have the money or don't want to spend much money to buy an oscilloscope, don't worry, I have this covered. This is the DSO138. It's a 1-channel 1 MHz digital storage oscilloscope. It's small, easy to use and very affordable. And in this video today, I'm going to show you how to use it. This is the DSO138. It comes in a package like this one. In this package, you find the cable used to connect to the oscilloscope and the device that we want to visualize a waveform from. We have the module itself, which is well built and looks very nice. And we have some documentation about this device. It comes with 2 documents. We have the very first one, which specifies how the module is used and also contains the schematic of the whole device. So you can use this to build yours. Well, this is not what we're going to use in this video. And right here you have the other manual. This other manual shows how the board is built, how the components are placed, so that you can buy the components and also buy a virgin PCB among all the components by yourself by following these instructions. So this is very good. And on the other side here, you're going to see a flowchart of how things work on this device. As you can see, this device is powered with a DC 9 volts. We have DC 9 volt written on the module, but it can be powered with the power supply ranging from 8 volt to 12 volt without a problem. I'm using this 12 volt 5 amperes DC power supply to power this oscilloscope. So this is how it displays. Okay, now let's go to the switches. We have 3 switches here. The first switch is the coupling switch, which means that if we want to measure an AC signal, we flip the switch to the AC parameter on this switch here, and on the LCD it automatically indicates there. If we want to measure a DC signal, we flip it to the DC side. It indicates there, and whatever signal we are measuring here should be DC. And then if we want to completely isolate the input to the ground, we flip the switch to the ground side. These other 2 switches here are the sensitivity switches. The first switch here, where we have 1 volt, 0.1 volt and 10 millivolt, is used to set the voltage for the signal we are measuring. And down here, the sensitivity number 2 is the multiplier, which means that for each division we have here on the voltage scale, 1 square is equal to 1 volt. Depending on the multiplier here, you will see that, let's go to DC, you see that if we select 1 volt here, we have 2 volts here because the multiplier is set to 2. If we set the multiplier to 1, you see the voltage goes to 1. If we set the multiplier to 5, you see the voltage goes to 5, which means that for every division here, 1 division corresponds to 5 volts. So let's go to the buttons. We have 4 buttons here. The first button is the select button. As you can see on this display, we have many parameters. We have the time scale, we have the auto, we have the falling or rising edge. We have all these parameters on this display here can be changed. And to change any parameter on this particular display, we have to select it. So this select button is used to select those parameters. So let's select auto. If we select auto, you see this particular, it highlights auto on the display. We go to the rising edge, it highlights it. So that's how you can select also the cursor on the voltage scale, so we can change those parameters. And then we have 2 other buttons. We have the plus button and we have the minus button. These buttons here are used to adjust the parameters selected by this select button. right here we have on the time scale. So if we want to increase the value, we just go on the plus. Oh no, we're decreasing. We just go on the plus, and you can see that the values change. You can decrease it with the minus button. So these two buttons here are used to adjust the parameters selected by the select buttons, and then the OK button is here to validate the adjustment made with these two buttons. So if I decided to put 1 millisecond here, I want to validate that, I just come and click on OK, and now it is selected. And you can see that we have one button here as well. This button is the reset button, which means that we can reset everything from scratch, which is like restarting the whole oscilloscope. So let's just click on that one. You see the oscilloscope restarted. So now let's plug the probe to the oscilloscope. One thing that this oscilloscope has is that it has a ping that generates a 1 kilohertz signal. So we're just going to connect this clip to this particular connector here, and then you see that we have a 1 kilohertz signal being displayed on the LCD. So you can see how we play now with those values. We change the sensitivities. So generally, these three buttons here are for probe calibration. See that when we come to 1 volt, sensitivity 2 is on 5, the signal goes very small. So to demonstrate to you how this oscilloscope works and how good it is, I prepared this circuit. This is a linear power supply. As we all know, a linear power supply has a transformer, a rectifying circuit, and a capacitor on the output for filtration. So right now, I'm going to plug my oscilloscope to the transformer output, and then to the rectifier output, and when the capacitor is plugged. But before we go into that, we always have to make sure that we calibrate the probe of this oscilloscope properly in order to make sure that we are measuring AC signal. Since the voltage from the transformer is AC, we are going to calibrate the probe by setting this switch to AC right here. Okay, it's already done. So the next thing we have to do now is to plug the probe of the oscilloscope to the transformer. So as you can see right here, we have an analog signal displaying on the LCD right there. You have some values right here. We have the maximum voltage, the minimum voltage, the average voltage, the VPP, the V peak to peak, the mean square values. We have the frequency, in my case is 50 Hz, which is normal. We have the duty cycle and other parameters which I don't even understand. So the next thing we're going to do is that we're going to plug the transformer output now to the rectifier, and then measure the signal on the output of the rectifying circuit. Let's do that. Okay, now let's connect the oscilloscope to the output of the rectifier. After connecting the oscilloscope to the output of the rectifier, the next thing we have to do is to go to the coupling switch again and set it to DC, since at the rectifier output we have a DC signal. Let's go there. So that's done. So you can see right here that we have a DC voltage being displayed here. You see the frequency changed to 100 Hz and the other values as well. So it works well. So now let's connect the capacitor so you can see how we're going to modify that signal by filtering the output of this stuff. So this oscilloscope is good for students and independent makers who don't need something very expensive to visualize waveform of their circuit. Thank you so much for watching this video. If you liked it, give me a thumbs up and don't forget to subscribe to my channel for more. I'll see you next time on the next one. Goodbye.